Assalamualaikum to all of you. First of all, I will introduce myself. My name is Mohd Fizwan Zulkifli, and I study at University Malaysia Pahang in a degree of mechanical engineering. Today I will discuss about thermodynamic, which is the topic of in chapter 5, which the topic is the second law of thermodynamic. In this chapter, there is 5 subtopics. Which the first is introduction to the second law. Second is heat engines. Third is energy conversion efficiencies. Fourth is refrigerators and heat pumps. Fifth is reversible and irreversible process, and the last but not least is Carnot cycle and device. First of all, I will talk about the introduction to the second law of the thermodynamic. The second law of the thermodynamic is to establish the direction for the process. It provides a mean for measuring the quality of energy. Then it establishes theoretical limit on performance for the device. And the last is establish condition for equilibrium. I will give you an example for the second law of thermodynamic. Imagine this is a box which is in a state of 40 degrees Celsius. After a few minutes, I take about 15 minutes. The box will turn into some other degrees. The degrees of the box will decrease. There is some general features of spontaneous or natural process of the second law of thermodynamic. Firstly is the water flow from the downhill, and the second is object falls to the earth and never rebound to their original elevation. For the natural processes, power plant inject hot fluid into stream that cannot be recovered to do useful work. Also, the refrigerators that we always use at the home inject heat into the surrounding that cannot be recovered to do useful work. For the common experience, I will talk about some automobile never extract the heating value of the gasoline fully and convert it completely into kinetic energy. Hot exhaust gases are emitted to the environment, and that energy cannot be recovered to do work. Whereas the heat exchangers cannot be run backward to reheat and recool the fluid steam. Next, I will talk about the quality of energy. The quality of energy is related to how much work we can get out of the energy. For an example, high temperature energy can produce more work than low temperature energy. Some definition, they state that classical thermodynamic introduced the second law where a device called heat engine, which between thermal reservoir. A thermal reservoir is a large body that can absorb or supply heat without a noticeable. Temperature change depend on how large on quantity of the heat. For an example, a thermal reservoir is an ocean, lake, atmosphere, room air, and a furnace burner. For a heat sink, reservoir that absorbs heat. For the heat source, reservoir that supplies heat. I will make it simple, which is condenser. There is a energy out and will turn into energy sink. This is what we call heat sink, which is receiver that absorb heat. Second is energy source. Energy source that we put in energy and it will turn into a boiler. This is what we call heat source. Then I will talk more about heat engine. A heat engine is any device that convert heat energy into useful work. This is an example of a chart of the heat engine. Firstly, boiler. Secondly, turbine, condenser, and lastly, pump. The process is always rotate and rotate again. Heat engine. Heat engine is a continuous operating thermodynamic system across the boundaries of which only heat and work can flow. In this definition, the key words are continuously operating. This implies that the working fluid in the heat engine undergoes a cycle. Heat engine differ considerably in detail from one another. They all share the following characteristic, which is they receive heat from a high temperature reservoir. They convert part of this heat to work. They reject the remaining waste heat to flow. Heat to a low temperature reservoir. They operate in a cycle. The characteristic of heat engine: they can receive heat from a high temperature sources. They convert part of this heat to work. They reject the remaining waste heat to a low temperature sink. They operate on a cycle. For characteristic of a heat engine: high temperature source, into a heat engine, and then turn into low temperature. In this state, energy will enter the heat engine, and in this state, work will out, and here energy will be out also. There are two types of heat engines, which is direct and reverse. For a direct heat engine, This is the type of hot direct heat engine. And if I change this error, this will be a reverse heat engine. In a direct heat engine, Q1 is the supply to the engine at the temperature T1. Inside the engine, part of the heat transfer is converted to work. A quantity of heat Q2 is rejected to a reservoir at temperature T2. In a reverse heat engine, a work transfer into the device occurs. This shaft work is then used to pump heat from a low temperature reservoir at temperature T2 into a high temperature reservoir at T1. Example of a heat engine is a steam power plant. In a heat engine, there is a thermal efficiency. There is for a general performance, equal to desired output over required output. For heat engine, there is a thermal efficiency which is equal to no work output over total heat input. For formula is equal to W net output over energy in, or we can conclude the formula as equal to over and the last is it will be 1 minus heat out over heat in. This is the last formula for heat engine. I will proceed with the third subtopic, which is energy conversion efficiency. Energy conversion efficiency is that indicate how well an energy conversion is accomplished. Work to work conversion equal to 100%, then the conversion limit with no friction. If the work dissipation to heat is equal to 100% conversion limit, that is with no heat or no other heat loss. Then I will proceed with the fourth subtopic, which is refrigerator and heat pump. I will talk about the example of the refrigerator and heat pump. In the refrigerator and heat pump, these two process will rotate together to make the process work. For the condenser, the surrounding medium such as the kitchen air. For the evaporator, the example is refrigerated space. For the refrigerator cycle, the cycle of this refrigerator cycle will rotate each again and again. Firstly, condenser, secondly air, third compressor, fourth is evaporator, and the last is expansion valve. For the refrigerator, then I will talk about coefficient of performance of we call it COP. The formula of COP is desired result over required input. This formula can be applied into the first law to the cyclic refrigerator. Next, then I will proceed to the fifth topic, which is reversible and irreversible process. Reversible process is a process that can be reversed without leaving any stress on the surrounding. For the irreducible process is a process that are not reducible. For the definition of a reversible process, the reversible process is a process which can be reversed without affecting the environment. For an example, is a frictionless modular. Quasi-static boundary work, quasi-static heat transfer, or reversible for an infinitesimal. A change in state of the system such that if the system is restored to its original state by any man, so there is no net effect on the universe. This means that the system and the surrounding are restored to their original state. For a reversible heating, each incremental increase of temperature dt of the heater result in heat transfer to the water and a corresponding increase of the water temperature. For slow enough heating, the state of the heater and the water are nearly equilibrium state, and the process is said to be an equilibrium process. Irreversible process, all are real process are irreversible. Irreversible process basically occur due to, firstly, is a friction. Friction basically always cause the heat transfer to the surrounding. It cannot use this lost energy to reverse the process. Second is heat transfer finite. Heat transfer cannot reverse the process without a heat pump. For an example, electricity required for heat pump would affect the environment. Third is non-consistent expansion or compression. Expansion or compression. And other irreversibilities is mixing of gases, electric resistance, chemical reaction, and the last is inelastic deformation. Other definition for reversible or irreversible process is internally reversible process. No irreversibilities occur within the boundaries of the system during the process. Externally reversible process. No irreversibilities occur during the boundaries of the system during the process. Totally reversible process. Internally and externally reversible. For the test of reversibility, we use a device of thermodynamic device external to the gas that violates the second law. Assume that system return to its original state. The result heat transfer from a lower to a higher temperature. Work of compression using a single reservoir. Both of these results are denied by the second law. The process is thus internally irreversible. Then I will proceed into the last subtopic, which is Carnot cycle. Carnot cycle is first proposed in 1924 by French engineer named Sadi Carnot. A cycle that working on a reversible process serves as starting point to develop actual cycle. Actually, there is 4 types of Carnot cycle. The first is isothermal expansion. Second is adiabatic expansion. Third is isothermal compression. And the last is adiabatic compression. For the first isothermal compression expansion, it occurs at the hot reservoir. Second, it always occurs at the insulating stand. Third, at the cold reservoir. And the last is at the insulating stand also. The process of the Carnot cycle is a reversible, constant temperature heat addition from a high temperature reservoir, and irreversible adiabatic expansion, a reversible constant temperature heat reaction to a low temperature reservoir, and reversible adiabatic compression to the original state. The Carnot cycle. The Carnot cycle is a fully reversible cycle. Each process is itself reversible, can be either a work producing cycle or a work consuming cycle, can be operated in either direction, represent an idealization of most power cycle because of its reversibility and generality. There is 3 kinds of device, which is Carnot engine, Carnot refrigerator, and Carnot heat pump. These devices are generally same as previous device. However, the system working on reversible process. For the coefficient of performance of or efficiency of Carnot heat pump and refrigerator usually compressed as the coefficient of performance. equal to desired output over required input. This formula is same as thermal efficiency for the heat engine. Then I think that's all for me for the second law of thermodynamic. Thank you.